to look at dimension in physics, dimension of physical quantities. Dimension of physical quantities. My name still remains your teacher, Mr. Abdulgani Adamu Isiaka. Now, let's go to dimension now. Now, any quantity which can be measured in units of length is said to have dimension. Any quantity which can be measured in unit of length is said to have dimension of length L. So also any quantity which can be measured in unit of time is said to have a dimension of time t, and any quantity which can be measured in the unit of mass is said to have a dimension of mass m. Now in physics, the word dimension has a special meaning. The word dimension has a special meaning. It usually denotes the physical nature of a quantity. It usually denotes the physical nature of a quantity. Now, the symbol that are used to specify length, mass, and time are L. Please take note of this. M and T. These are very crucial. Length, M and T, respectively. They are usually enclosed in brackets, like just as it is written here. Now, the dimension of velocity are written as, now we want to look at, for example, we start with speed. Let us start with, okay, the dimension of velocity are written as velocity. Velocity here now is written as displacement over time. Displacement over time, which is our displacement is length L all over what? T. L over T. Now, which can be written as LT inverse. LT inverse. LT minus 1 raised to the power of minus 1. Are we clear now? Just like 1 all over 2, which can also be written as 2 inverse. Are we clear now? Now, we can also have speed. Speed, which is distance over time. Our speed. If you look at our speed is what? Distance over time. Now, our distance is L, which is length over T. Are we clear now? Now we can have it to be LT inverse. LT inverse. Then we can also have our linear acceleration. You can have our linear acceleration. Linear acceleration. Which is what? Velocity over time. Velocity over time. Now our velocity, we know it is LT inverse all over T. LT inverse all over T. Therefore, our linear acceleration can also be written as LT LT minus 2. LT minus 2. That is to say, you know, if you take this one to here, it becomes minus 2. So instead of we have, you know, this is 2, this is t, this is, let's say for example, we have, I'm just trying to simplify now, I have minus 1 minus 1 because of we have double t minus 1, sorry. So we can, at the end of the day, we can have LT minus 2 because we have t 2. Now we can also have our force, which is what? Mass multiplied by acceleration. Mass multiplied by acceleration. Now we have our m, mass to be m, and we have our acceleration to be LT minus 2. LT minus 2. Therefore, at the end of the day, our force is going to be m LT minus 2. Hope you are getting it now. So force is equal to LT minus 2. I say we can also have our work. Now from definition, our work is force multiplied by distance. Force multiplied by distance. Now, if you look at our force, you know from what we've done so far, our force is MLT minus 2. That is for the dimension now. And our distance is what? L. Our distance is L. So, if you do everything together, carry everything together, our work now will give us M. We have how many L here? 2L. L times L. That is L squared. L2 all over T all over T all over T2. Over T2. That is for force. That is for work. That is for work. That is T minus 2. Sorry. Now, if we want to, our power now, let us look at power now. From our definition, power is what? Power is work done over time. Work done over time. Now, what is work done? Our work done is ML 2 T minus 2 all over T over T. So at the end of the day, our work done so our work done is going to be okay, our power is going to be P L2 T minus 2. Therefore, our P now, our P will now give us, our P will now give us ML2 T2 MLT T2. Now, pressure. Let us look at pressure. Pressure, which is pressure is force over area. Now our force is ML2, MLT2, MLT2 all over L2. Therefore, pressure now will give us ML minus 1 T2. So let us look at momentum. Momentum. We also have our momentum is mass times velocity. Mass times velocity. Now we are going to have our mass, which is m, multiplied by our velocity, which is lt minus 1. Now we are going to have momentum is what? M lt minus 1. Now impulse, let us look at impulse. Impulse is given as force multiplied by time. Force multiplied by time. Therefore, our impulse now is going to give us 4. Our 4 is ml t minus 2 multiplied by t. So, which is going to give us ml t minus 1. This is plus your law of indices. So this one returns to 1. Then we can also have moments. Let's look at moments, which is giving us first as distance. First as distance. So our moment is our moment. Our moment is what? MLT2 times L. This is our distance. So we are going to have MLT minus 2 T minus 2. That is LLT minus 2 T minus 2. So we are still proceeding. So let us look at density. Density now. Density is giving us mass over volume. Mass over volume. Our mass is m and our volume is L3. Now, so density now. Density is equal to m L minus 3. Therefore, this is ml minus 3. So let us look at some example. Let's look at some example. Find the dimension. Find the dimension of force. That is A, force, B, pressure, then C, work. So we are going to have Solution now. Solution we have for A, which is force. Your force is what? Mass times acceleration. Now, what is our mass? Now, our mass is M. Enclose it in brackets, multiply by our acceleration. Our acceleration is LT minus 2. Now, at the end of the day, we are going to have MLT minus 2. That is for our force. Now, for the second one, which is B, which is pressure, our pressure is giving us force over area. Now, our force is giving us dimension of our force here now. All over dimension of area. Now we are going to have that of dimension of pressure. Pressure now is going to give us M, dimension of our force is ML T minus 2 all over area. Our area is L2. So at the end of the day, we have M minus 1 T minus 2. Therefore, C, we have for work, and our work is dimension of force times distance. Dimension of force as dimension of distance. Now, what is dimension of force? ML T minus 2 multiplied by our L. So at the end of the day, we are going to have ML 2 T minus 2. T minus 2. Let us look at another example. Let's look at another example. They said about 2, find the dimension. Find the dimension in electrical system. Electrical system of the following. We have A, we have electric charge. Then B, we have electric potential. Then C, we have capacitance, which is given as C. Now let us look at solution now. Now, the electrical charge. Electric charge is given as current multiplied by time. Is given as current multiplied by time. Now, our current is what? A ampere. And our time is what? T. So at the end of the day, we have AT. Now for B now, we have electric potential. Electrical potential which is what? Voltage is given as power over current, which is, so our power now, if you look at the dimension of power, we have M, L, 2, and T minus 3 all over A. Okay. Therefore, so that is, therefore, we are going to have our voltage. Our voltage is going to be, our voltage is going to be M L 2 T minus 3 A minus 1. Now for the third one, which is capacitance. Capacitance is given as charge all over potential. So it's given as, our charge is 80 for what we did, the first one we did. All over. Then our voltage now, potential voltage, which is charge over potential, and our potential is electrical potential, which is limited as voltage, is given as M L2 T minus 3 and A minus 1. So at the end of the day, we are going to have A2 T4 M minus 1 L minus 2. That is that about that. So we are through with that. So we are through with that. So I want us to look at another example. Now we were asked to find, let's just look at it, another example. Let us example 3. So a small mass is suspended from a long thread so as to form a simple pendulum. Now they said the period period T of the oscillation depends on the mass m, the length L, and the acceleration g of free fall. At the place concerned. Now we are given T to be K, the period to be K X, L Y, and G Z. That said, where X, Y, and Z are unknown. And K is 2D. Now I have to find the value of X, Y, and Z. Find the value of X, Y, and Z. Then hence derive an expression relating T, M, N, and G. Then 2 derived expression relating T, M, L, and G. Now let's look at the solution. We have number 1. Our T is equal to Km L Y and G Z. Therefore, T is equal to, from the said K, from the equation they said the period of the T is equal to the mass, the length, and relation G of free fall. Now, our M X L Y and our solution free fall is LT minus 2 Z. Therefore, our T is going to be MX LY. If you open these brackets now, you have L Z, then L minus 2 X. Therefore, relating what our T is from what we were given before. So our T is, we have M to be 0, L to be 0, then T, which is equal to MX L, add this our L together, Y love indices, Y plus Z. Then our L is going to be then our t is going to be minus 2x. Now comparing the indices now. Comparing indices, x equal to 0, equation 1, y plus z equal to 0, equation 2. Then our minus 2z now. Minus 2z. So this is supposed to be 2z, not x. Minus 2z now equal to 1, which is equation 3. Therefore, our z will give us minus 1 all over 2 for what our z is. Then our y will give us 1 all over 2, and our s will be what? 0. How does our y is equal to 1 over 2? You know, we said y plus z equal to 0, and we know our z is half, minus half. So y is equal to minus 1 all over 2 equal to 0. So definitely y is what? Half. Is equal to half. Definitely from our, we all know that from the equation s is equal to 0. Now for 2 now, t equal to k m0 l 1 over 2 and g is minus half. Therefore t is equal to KL all over 2 all over G 1 over 2. So we are going to have, bringing our K out, we are going to have roots. This half will cancel this half. We are going to have L over G. Therefore, our T will be equal to 2 over L over G. So T is independent of the mass. T is independent, where T is independent of the mass. So hope you enjoyed the lesson. We are going to continue in our next class, which is going to be motion.